Namaskara students, welcome to We Karnataka KCET and Boards. I'm Diksha Kaushal, your chemistry master teacher. And students, we all know that your PUC2 exam are very near, so that's why practice is very important, especially the sample papers and the model papers, right? So today we are going to do one of the model paper, right? The chemistry section I'm going to take up. You have in evening you have done bio, right? Yesterday you did physics and mathematics, so last session is for chemistry. Okay, so are you all ready for this? Everybody in the comment section, let me know. Everybody, am I visible? Am I audible to all of you? Please let me know in the comment section if everything is clear, right? If I am visible and I am audible to you, right? Okay, students. Yes, everybody. Yes, Mehraj, Manikanta, PK, Khushmohit. Yes, how? Yeah, it's been such a long time, right? It's been such a long time. So we gave you time for your self-study. And now we are going to do the revision with the help of model papers, right? Okay, yes. Chalo. Now, let's start this. The first question, guys, on your screen, and I want all of you to answer this, right? Whether it's correct or wrong, I want all of you to at least give the answer of that, right? Okay. Yes, everybody. Hanji. Everyone, am I visible? Yes, Karun. Yes, Sandhya. Sandhya, you should be ready by now. When you will get ready? Just before the exam. Is it? Okay. So yes, what is the correct answer of this? PK is saying D. Okay, chalo, let's see. First question is the role of CO2 in Kolb's reaction. So basically, what does CO2 do in Kolb's reaction? So what is Kolb's reaction? Now in this, what exactly happens? CO2, this is CO2, right? Okay. And what will happen? This is partially negative, this is partially positive, this is partially positive, right? So basically it will act as a weak electrophile, right? It will act as something, wait, I just wrote this incorrectly. Oxygen is partially negative, this is partially negative, this is partially positive. So what will happen, right? This bond will shift here, this bond will shift here, right? And from this position, from this carbon, it will behave as a electrophile in the Kolb's reaction. So it will act as a weak electrophile. So answer is C is the correct answer, right? Okay, students. Now next is the DNA linkage between different nitrogenous bases, right? If you talk about the DNA linkage, that has phosphate linkage, that has peptide linkage, glycosidic linkage, or the hydrogen bonding. Yes, everybody. Srinivas. Yes, beta, this is model paper 1. Yes, you are correct on that. Right. So, DNA, the linkage between different nitrogenous bases is what? A. Phosphate linkage. No, that is not between DNA linkage between different nitrogenous bases. Like you have A, right, with T, right? You had G with C. It has 2 hydrogen bonds. It has 3 hydrogen bonds. So it has hydrogen bond linkage, that is D is the correct answer. You also need to know that A with T is forming 2 hydrogen bonds. G with C is forming 3 hydrogen bonds. Okay? Okay? Yes. Now, next students we have, next is, beta everybody, the complex. Now they are talking about a complex, right? Okay. Yes, very good, beta, very good, shabash. The complex PtCl2 dot 4NH3Br2 is treated with excess of AgNO3 solution. 2 mole of AgBr precipitated out. The primary and the secondary valency of this complex, basically this is from coordination compound Werner's theory, right? This is from coordination compound Werner's theory, right? Manikarnika with our answer. Ma'am, respond with our answer. Beta, yes, I am responding with your answer only, right? Okay, I'm responding with your answer only. Hanji, I'm looking at your answers. Don't worry about that. I'm looking at your answers that what you are telling. Right. Okay. So D. Mehraj is saying D. Manikanta is saying B. Okay. Chalo, let's see. Firstly, though the complex, this is treated with excess of AgNO3. With AgNO3, it will react with Br, right, negative to give AgBr, right. They are saying that two AgBr are formed. That means two Br negative and two AgNO3 were reacted. That means outside this coordination bracket, you had two Br, right? Okay. Now PtCl2 4NH3 you have here, right? So if I want to write it as PtCl2, this will be NH3, right? This will be 4, right? PtCl2 NH3 4, right? Now they are saying the complex is treated with excess of this 2 mole of AgBr precipitated primary and secondary valency you need to tell them, right? So beta, secondary valency, firstly to calculate the oxidation number here. If this is -2, this is going to be +2. So this is x minus 2 plus 0 is equals to +2. So x is going to be +4. Acha, what is oxidation number? Oxidation number is the primary valency. Oxidation number is the primary valency, right? Oxidation number is the primary valency and coordination number is the secondary valency, right? Coordination number is the secondary valency. Coordination number is 4 plus 2. So coordination number will be 4 plus 2 is equals to 6, right? So this is your secondary valency. This is your secondary valency. Now tell me what is going to be the answer. It is 4 and 6. So answer is going to be C is the correct answer, isn't it? Everybody, is that clear to everybody? C is going to be the correct answer here, right? Chalo. Next thing, next is, beta, is that clear to everybody? Right? Is that clear to everybody? Right? If that is clear, to just give me thumbs up in the comment section that yes, ma'am, that is clear to us. Okay? Yes? Chalo. Okay, Srinivas, Manikanta, Mehraj, is that clear? PK. Next question is, enantiomers are non-superimposable mirror images of each other. A racemic mixture, basically two statements are given to you. You have to tell whether they are correct or incorrect. A, you are telling, Manikanta is saying A. Okay, very good. Chalo, shabash. Enantiomers are non-superimposable mirror images. That is the correct statement. Second statement is a racemic mixture shows zero optical rotation. Racemic mixture means which has both inversion and retention. So there is zero optical rotation because inversion and retention compound will cancel out each other. So this is also the correct statement. So answer is both 1 and 2 are the correct statements here, right? Very good, very good. Next question is, next is the most stable manganese compound is. Beta, the most stable manganese compound is. Because manganese, first we will find out the oxidation states here. So here oxidation state is 2x is equals to 2x minus 8 is equals to 0. Not 8, it should be 14 is equals to 0. 2x is equals to 14. So x is equals to plus 7. Okay. Here it is x minus 4 is equals to 0. X is equals to plus 4. Here it is x minus 4 is equals to 0. And this is x is equals to plus 4. Right. And here it is x is x is equals to 2 only. Now, here, if you talk about the most stable manganese compound, right, oxidation state, so is not telling us that, right, because two of them have same oxidation state. But beta, always remember the oxides in the like if you talk about +4 oxidation state, the oxide is going to be more stable as compared to the fluoride. So answer is going to be C, right? Answer is going to be C. That is MnO2 is going to be the correct answer here, right? Okay, chalo. Next is they are asking Among the following, now beta, among the following, alkyl benzene, which one will not give benzoic acid on oxidation with acidic aminophore? Very, very important question. Okay, very, very important question that is based on one of the exceptions, right? Okay, so if we talk about this thing here, guys, always remember that if you have isopropyl group, isopropyl is this group, isopropyl is this kind of group, right? Okay, if you have this kind of group, then it will not, wait a minute, isopropyl, nahi. If you have this kind of group, not isopropyl, by mistake, it should be tertiary. If you have 3-degree alkyl group, if you have 3-degree alkyl chain, in that case, that chain will not be converted into COH group. Otherwise, any other group will be, any other alkyl chain will be directly converted to COOH, right? So that is why this chain is present here. So answer will be B is the correct answer, right? Okay. Answer is B is the correct answer because this is CH, this is not tertiary. Okay, we can't say this is exactly that thing. Okay, this alkyl chain itself is not tertiary. This alkyl chain is tertiary. Okay, so answer is B. Very good. Next beta, next question is an ambidentate ligand. Ambidentate ligand mane? Ambidentate ligand, the one which has two donating sites. Okay, so two donating sites, chlorine, so it does not have. OH negative, definitely not. Cn and NO2. Now you need to tell me between Cn and NO2 which is the correct answer. Yes, beta. Between Cn and NO2 which is the correct answer, students? Which is the correct answer? Cn and NO2. This is NO2 positive over here. Right? So NO2 positive is not an ambidentate ligand. NO2 is an ambidentate ligand. So this will also be eliminated. Answer will be B is the correct answer. Right? Answer will be B is the correct answer. Sure. Next students, we have E0 value. E0 value of Fe2 positive Fe, Zn2 positive Zn, Sn2 positive Sn. This is these three E0 values are given to you. Which metal is or are act as sacrificial electrode to protect iron from rusting? Okay, which of the following is going to act as sacrificial electrode to protect iron from rusting? Right. So if we talk about iron, it is also oxidation number is decreasing. It is also reduction. It is also reduction. It is also reduction. Here oxidation potential is minus 0.44. Right. Okay. And you need to identify something. Right. This is minus 0.76. This is minus 0.14. Okay. Okay. Sacrificial, okay, which is going to sacrificial electrode, which is going to be the sacrificial electrode to protect iron from rusting. To protect iron from rusting, right? That means the opposite case. That means if you want to stop the oxidation here, the other part should behave as a reducing agent, right? The other part should behave as a reducing thing. So basically, if you want if you don't want rusting to happen, that means you don't want this thing to happen. You don't want iron to get converted to Fe2 positive. You want iron to stay into iron zone only, right? Okay, so in that case, what you will see that both zinc and tin, right, they will act as sacrificial electrode to protect iron from rusting, right? Both will protect iron from the rusting. So answer will be both zinc and tin is the correct answer. No beta, both zinc and tin will act as this. Okay? If you talk about this thing, na, both will act as, because if you talk about Fe2 positive to Fe here, right? If you talk about Fe2 positive to Fe, that is given to be, that means 2 positive to 0, it is given to be minus 0.44 this. Okay? So if you talk about from Fe to Fe2 positive, it is given to be 0.44 volt, right? Okay, so we need to have lower than that thing. Lower than that is for both minus 0.76 and minus 0.14 are both lower than that, right? Okay, right? Okay, ji. Understood? Beta, that means which is going to protect it, which is itself going to get oxidized, right? Rather than making iron oxidized. Okay, so basically, which is going to protect, like for example, this is iron. Okay, so when you have some layer over it, when it protects and it sacrifices itself, right, to protect the iron inside, that is called sacrificial. Okay, that is called sacrificial, right? So that's why, because both have less than that, so that's why both will act as sacrificial, right? So answer will be E, both zinc and tin is the correct answer. Okay, next is the chemical change, the chemical name of phosgene. Phosgene is what? Phosgene. Phosgene, students. Phosgene. There was also one of the gas that was in initial gas of Bhopal gas tragedy, if you have ever heard of that. Right? MSC is a very dangerous chemical. The initial thing was phosgene gas. Right? So phosgene is nothing but it is carbonyl chloride. Okay, carbonyl chloride. This is there in haloalkanes and haloarenes. Right? Okay. Next, students, we have all natural and artificial radioactive decay of unstable nuclei take place by all natural and artificial radioactive decay. Natural, you say, or artificial radioactive decay of unstable nuclei takes place by zero order reaction, half order reaction, first order, and second order reaction. Yes, students, what is the correct answer? D, C, C, Manikanta is saying D, then Shivna C, A, C, C, okay. Students, so radioactive decay, you will usually see that in first order reactions, okay. So answer is going to be C is the correct answer, okay. First order reaction, that is C is the correct answer, okay. Got it? Okay, next we have, you need to match the following things here. So this is basically from biomolecules. This is regarding the hormones. So if you talk about the hormones here, everybody, if you talk about those who are from medical background, right, they will find it very easy. From non-medical background, they will find it very tough, right? Okay, so let's do it this way. If you talk about estradiol, that is a female hormone, that testosterone is a male hormone, right? So estradiol, if you talk about this, it is basically female hormone that is preparing the uterus for implantation of fertilized egg. So that means we can say D is for 2. D for 2 is present. D for 2, wait a minute, D for 2, na? D is development of response. Wait a minute. Development of secondary female characteristics. Okay. So that means D for 1, we can say. Yes, students. So that means D for 1 because it is in both the cases, okay. It is also used for development of secondary female characteristics. Its also role is to for the implantation of egg and menstrual cycle, all these cases, right? So we can say then D is 1, okay. D is 1 in these 3 cases. So we can say this is eliminated. Testosterone is male hormone, so it will be responsible for secondary male characteristics. So C is 4th. C is 4th over here. So this is also eliminated, right? Now, what is mineral octiocoids, right? So basically, this is a hormone that balances the minerals and salts, as you can see in the name itself, right? So it controls the level of secretion of water and salt by the kidney. So B is 5th. B is 5th. So answer is B is 5th. Then you have A, that is glucocorticoids, right? That is for responsible for carbohydrates metabolism. So answer is B is the correct answer. Okay, B is going to be the correct answer. But estradiol is also one of the hormone, right? Estrogen is also one of the hormone, right? So estrogen, estradiol, right? They are, we can't say they are same hormones, but yes, they are female hormones, like progesterone. These are female hormones, right? Okay. Now, next is uh, para-amino Para-aminoazobenzene is prepared from benzene disonium chloride and aniline in which medium? Now, guys, para-amino, para-amino, if you talk about on the para position, you have aminoazobenzene, right? Aminoazobenzene. Aminoazobenzene is prepared from benzene disonium chloride and aniline, right? If you talk about this thing here, you have aniline, right? You have aniline, right? From there, you are preparing benzene disonium chloride, right? Okay, benzene disonium chloride. Okay. Benzene aniline. Okay. Okay. So this is basically, they're talking about coupling reaction here. So you have this thing, right? You have NH2, right? And you have benzene disonium chloride, or you can just directly write here N2Cl positive negative, and here you can write this NH2. So what will happen from the para position, this will be eliminated and this thing will be formed. So this happens in the acidic medium. So A is going to be the correct answer, right? This happens in acidic medium, not the basic medium, right? Okay, guys. Okay, next we have the chemicals used to convert commercial alcohol into denatured alcohol. CuSO4, pyrrolidine. CuSO4 is definitely there. So we'll just eliminate these two things. Right? Now, firstly, you need to tell me it is pyrrolidine or pyridine, which is used to convert, right? Okay? Which is used to convert NH. They are not talking about these two things, students. They are not talking about aniline, or they are not talking about benzene disonium chloride. They are asking the medium here, right? In the medium. The medium is acidic only, right? The medium is acidic in which this coupling reaction will occur, right? Okay, the medium is acidic only. The medium is not basic, right? Aniline is basic in nature. Now, CuSO4 and pyridine is the correct answer. So, C is going to be the correct answer here, right? Okay. Next is during osmosis, the solvent molecules are moving from which part? Hypotonic means the one which has more osmotic pressure, to hypotonic. Hypotonic to hypotonic, there is no such definition, right? Okay, but you have to make that definition clear here, right? Now, higher osmotic pressure to lower osmotic pressure, higher concentrated solution to lower concentrated solution. Yes, students, everybody, what is the correct answer? During osmosis, the solvent particles, they move from hypotonic to hypertonic, hypertonic to hypotonic, higher concentrated solution to lower concentrated solution. Only Manikanta is telling me the answer. Who else is going to tell me the answer? Srinivas is also telling the answer. Very good. A. Very good. So answer is going to be hypotonic to hypertonic solution. Okay. So answer is A is the correct answer. Now fill in the blanks. So now you have to solve fill in the blanks, guys. Okay. The first question is the melting point of interstitial compound is dash, then the pure metal. The melting point of interstitial compound as compared to pure metal. Interstitial compound means which has some mixing in the voids, you have mixing of other atoms, right? So in that case, the melting point, because of more structure, more bonding there, right? So the melting point is going to get higher, right? So melting point is going to be higher as compared to higher or greater or more, right? So answer is going to be yes. Answer is greater, right? Next is benzene disonium fluoroborate, right? On heating, decompose to, very, very important naming reaction. They are asking you, you have this N2Cl, right? This, when you have HbF4, it give rise to fluorobenzene. So answer is going to be fluorobenzene. Answer is going to be fluorobenzene. Fluorobenzene is going to be the correct answer, right? Okay, next question is the simplest hydroxy derivative of benzene. Simplest hydroxy derivative of benzene. On benzene, the simplest hydroxy derivative, guys. On benzene, just attach one OH. What you will get? What is the name? What is the name? I can't see your answers, guys. That is stuck at greater. After that, what happened? Huh? That is phenol. That is phenol is the correct answer, right? Okay. Yes, Abhishek, you ask something, then only I'll reply. I don't live in your mind to understand what exactly you are thinking to reply by my own. You need to ask me something. Okay. When a non-volatile solute is added to pure solvent, the freezing point. Non-volatile solute, guys, this is regarding the colligative properties. Colligative properties. So if you talk about depression and freezing point, for colligative property, boiling point will increase, vapor pressure will decrease, freezing point will decrease. There is depression in freezing point. Ma'am, good ma'am, you're teaching so beautiful. I loved it. Thank you so much, Manikanta. Thank you so much, students. Thank you so much. Okay, so if you talk about the vapor pressure, see, when you just remember one thing, that whenever we are adding a non-volatile solute, vapor pressure decreases. For example, you want to meet your favorite actor, you want to meet Allu Arjun, right? So what will happen, right? What will happen? There will be a lot of crowd, hai na? You have seen that case, right? So what happened in the crowd, right? Someone died in that, right? So what exactly is that? For example, you want to meet your favorite celebrity, right? So if you have too many bodyguards, you won't be able to meet them. So that means vapor pressure decreases, right? Because of the bodyguards. Non-volatile solute are the bodyguards. When vapor pressure decreases, this is the vapor pressure. A boiling point is when vapor pressure matches the atmospheric pressure. So now when vapor pressure decreases, the boiling point will increase, because earlier it was here, now it is here, but atmospheric pressure is same only. Now that is why boiling point increases. That is why you will say boiling point, there is elevation. But freezing point is when vapor pressure of solid is equals to vapor pressure of liquid. So earlier this is the vapor pressure of solid state. Okay? This is the vapor pressure of solid state. This is the vapor pressure without any non-volatile solute. Now this is the freezing point that it has to achieve. Now vapor pressure decreases. Now this is a freezing point that it has to increase. So there is depression in the freezing point. So here it is, freezing point decreases. Okay, understood? Yes, Srinivas, you can definitely get the PDF, right? On the channel only you will get the PDF. Okay. Okay. Next is you have ozonolysis of alkenes, that is going to followed by reaction of zinc dust. That means reductive ozonolysis they are talking about, right? Now here what exactly we do? Break the double bond, attach double bond O and double bond O on both sides. So it will give you what kind of thing? It can give you, depending on the kind of alkene you have, it will give you either aldehydes or ketones, right? Aldehydes and ketones will be formed here, right? Aldehydes and ketones will be formed here, because whatever alkene you have, you break that double bond, you attach double bond O there, right? You will get either aldehyde or ketone. Just take an example. You have, let's say you have CH3, this is CH3, this is double bond C. Okay, let's draw it like this. This is C, this is double bond C. Okay, let's draw it like this, C double bond, this is CH3, right? This is CH2, right? Break this double bond, it will be C double bond O, this is CH3, right? And this is the H, right? Let's say here you have, let's say for example, here you had this thing. Let's say here you had this kind of alkene. In that case, you would have formed, this is C double bond O, this is CH3 and CH3. So one aldehyde and one ketone was formed. Nothing else but aldehydes and ketones will be formed here. Right? Okay. Aldehydes or ketones will be formed here. Right? Okay. So answer is going to be this. Now, next is explain Swarts reaction with an example. Now, students, we are going to do some subjective questions. Okay, so are you all ready for subjective questions? Everybody, are you all ready? Abhishek, I am not getting your question. If anybody else can see your question, please let me know what he's asking. Now we have explained Swarts reaction. So Swarts reaction is basically a halogen exchange reaction, right? It is a halogen exchange reaction. Halogen exchange reaction. Exchange reaction. You need to mention this point there, right? And then you also need to mention that what are the reagents here, what we use here. So in Swarts reaction, we use inorganic fluorides, right? So for example, you use AgF, right? And this is used in with, you have Rx, where X can be chlorine or bromine, right? And then you will have the replacement of this X with fluorine, and you will have AgX will be eliminated, and this will be the full Swarts reaction. To form fluoroalkanes is called Swarts reaction. Very good. So now we are going to see how you're going to write down the theory part there. First you will write that, okay, this is Swarts reaction. Alkyl fluoride is created when, or you can say it is formed when metallic fluoride, right, when any metallic fluoride, it's AgF, CaF2, etc., is heated with alkyl chloride or alkyl bromide. The term Swarts reaction describes this phenomena. You can also write this is a halogen exchange phenomena, right? Then this is the reaction that you will mention here. You will give one example also always in the exam. When you write the general reaction, then also you will write the right. Okay. Okay, I think I forgot to send you that, Abhishek. Okay, so today I'll send that. Okay, don't worry, I already have those notes on this board, right? I have saved those notes, so don't worry. I think by mistake I forgot to send you that, but I'll send that today itself, right? You don't need to worry about that, right? So this is what you will have here, right? Okay. No, we can't say that these are not catalyst, Manikanta. These are not catalysts, so don't write this there. AgF, CF2, these are not catalysts. These are taking part in the reaction. Catalysts do not take part in the reaction, so you don't need to. And always remember, in subjective exam, if you are skeptical about something, don't write it there. If you are like, if they have not asked you whether it's acting as a catalyst or not, so if you're sure about that, only then write it there. Otherwise, teacher will cut down marks from there, right? So be sure about whatever you are writing, extra information that you are giving to them, right? Okay. Yes. Now, next is write down reactions. You have to write down the reactions that shows that glucose contains 5 hydroxyl groups, aldehyde group. Right, you need to show the reaction that glucose contains 5 hydroxyl groups and it also have a aldehyde group. So basically 2 reactions. Basically you have 5 kind of reactions in your biomolecules representing. So if they have asked this in model paper, they can ask you any of such reaction. They can ask you how you can say it has 5 OH group, how you can say it is having a N-hexane kind of chain. So that thing they can ask you. So firstly, though, we will tell them that how you can say that this is having 5 hydroxyl group. So that is actually shown by when you react this with acetic anhydride. Okay, this is acetic anhydride. anhydride. When this is reacted with acetic anhydride, what we saw that all the OH groups were replaced by this acetic group, that is OCOCH3. Okay, this is the acetic group, that is CH3 C double bond O. This is the group. So all the OH group were replaced by this particular acetate, you can say acetate group. So that's why it has formed pentacetate here. Now we can say that there must be 5 hydroxyl group already present in the glucose. Next is to show that it has aldehydic group. Now students, do you remember that aldehydic group we used to show it by a tolerance test, Fehling test, right? They were actually differentiating factor whether it is ketone or it is aldehyde, right? So aldehyde, all aldehyde give tolerance test for showing that glucose contain aldehyde group. We make glucose react with tolerance test, okay? And in tolerance test, there is no differentiation whether it will show aliphatic or aromatic will show this, right? Okay, so it does not differentiate that thing here, right? So that's why here what we will write, that this is reacted with silver nitrate, silver ammonium nitrate solution, that is tolerance test, right, in basic medium, and it is going to form gluconic acid and silver mirror from there. Right, gluconic acid means you will have the replacement of this CHO group will be oxidized to COO negative. Now we can sure say that this has a aldehydic group on this, right? Okay, this shows the presence of aldehydic group. Got it? Yes, students, is that clear? Is that clear? A catalyst like this, ma'am, this year we can expect, okay. See, I'll tell you a simple thing about exams, okay? A very simple thing about exam. Whatever publication you use, right? Yes, you can definitely expect. Reason is, when you see last 15 years trends, right? Last 15 years, 20-year trends, right? You will see that even you, if you analyze yourself last 10 years question paper, previous year question paper, you will also be able to predict the questions. So it's not a big deal to predict the questions, but the big deal is to answer it correctly. So I have seen that in so many books, there are wrong answers written and students say that, okay, this is the correct answer, just go through that book, and in the exam, they write the same thing. So be sure of that thing, that there should be no mistake in that book. Okay? Understood? Yes, Srinivas, Manikanta, is that clear? Okay. Next is define half-life period of a reaction. Write the relationship between half-life period and initial concentration of zero order reaction. Okay? Okay? Okay. Now, let us see how much we are left with. Chalo. If you see this here, first they are asking you about to define the half-life period. The half-life of a reaction is time required when 50% of the reactant is consumed or 50% of the reactant is left in that particular reaction. When the reaction concentration fall to 1/2 of its initial value. You can say 50% reaction is consumed, that is also the right way of writing it. Now we need to tell them the relationship of zero order reaction. For that, students, also remember this simple trick that T half is always directly proportional to A naught raised to power 1 minus N. Okay, so N is the order of reaction. If N is 2, so T half will be directly proportional to A naught. By this, you can verify whether your answer is correct or not, right? Okay, so now here, as you can see, T is equals to A naught. What is T, right? What is T? T is equals to change in the concentration by K, right? Okay, so now the relationship between rate constant, we already know this thing, right? From integral equation, right? Okay, from differentiation integral equation, we know that we have derived this thing, T is equals to A naught minus A by K, right? Now here, just replace this thing, this will be A naught T, I'll just solve it here. This will be KT, right? This will be, or you can just directly write it as T half is equals to your final concentration is half of the initial, so it will be A naught minus A naught by 2, right? Okay, half of the concentration is already gone, so it will be K, so it will be A naught by 2K. So T half is going to be A naught by 2K. You don't even need to do this, right? So basically here they have written that at T is equals to T half, A is going to be half of A naught. So this is what I have written here, and this is how you will have your answer. Right? Okay, students. Got it? Yes, everybody. Is the speed right? Am I too fast? Am I slow? Then let me know in the comment section. Right? Okay. Next is write the reaction involved in the preparation of phenol from cumene. So it's a very important cumene process, right? So basically what is cumene, right? Cumene is when on the benzene you have isopropyl. That means you have CH3, CH3, right? This is called cumene, right? So on adding oxygen, right? If you have, this is the cumene. On adding oxygen, what will happen? A peroxide linkage will be formed. That means instead of this H, you will have OOH over here. A peroxide linkage will be present after reacting cumene with oxygen. After doing the acidic hydrolysis, what will happen? You will have two things. From here you will have phenol and here you will have acetone. So answer will be phenol and acetone will be formed, right? In the end, phenol and acetone will be formed here, right? Okay. Yes, Srinivas, I'll be doing that, right? Okay. Next is iron 3 catalyst. If you talk about iron 3 catalyzes the reaction between iodine and persulfate ions in the reaction. So now we'll be talking about iron 3 catalyzes the reaction between iodine and persulfate ions in the reaction. Explain the catalytic action of catalyst iron 3 positive by using chemical reaction. So this is basically a very simple thing. So for example, you have this reaction. Okay, I'll just explain you here. So first you have to explain the catalytic property, right? What is catalytic property of transition metals? They are due to their change in the oxidation state that they can show. So catalytic activity of transition is due to ability to adopt multiple oxidation states, right? We know that iron 3 has two oxidation states, +2 and +3. So iron 3, guys, iron 3 catalyzes the reaction between iodine and persulfate ions, right? It will catalyze by changing its oxidation state. If you see this overall reaction is this one, this is given to you in the question, but you have to also write in steps. So in step you have Fe3 positive. Now what will happen? This Fe3 positive will be changed to, this is iodine negative, this is not F, this is I negative, okay? This is I negative. So what will happen? Fe3 positive on reaction with I negative. As you can see, I negative is going from -1 to 0. So there is increase in oxidation number. It is getting oxidized and it is getting reduced. It is getting reduced. It is getting oxidized, right? After that, we know that catalyst has changed the oxidation state. Again, this catalyst will react with this particular thing S2O8 2 negative. Now what will, do you know what this reaction is? Actually your titrations, okay? Iodometry titrations. From there, this question is from that particular scene, right? So this is Fe2 positive. It is oxidized to Fe3 positive. So a catalyst is one which can change the oxidation state and itself get back to the original oxidation state after the end of the reaction. So this is what is happening here, right? Next is study of actinoids element is more difficult, right? Why? Why lanthanoids are easy to study? Because actinoids are radioactive in nature, right? So actinoids are highly radioactive, making them hazardous to handle and requiring special safety measures. It's not possible to handle radioactive elements which have very low, very less half-life, right? So that's why it's not possible, right? So actinoids have complex electronic configuration which leads to variety of oxidation states, right? And chemical, if oxidation states, we know that this transition metal elements, they show variety of oxidation state, right? That's why they have like too many reactions, right? So if you talk about actinoids, they have like more than like even complex oxidation state as compared to transition metal. So that's why it is very difficult to study them, right? Third is scarcity and instability. As we know that they are not stable, their half-life is not at all, right? So actinoids are rare and have short half-lives, making them difficult to obtain and study over time. So it's not possible to study them. Next question is for the complex bit. Students, let me know in the comment section if that is clear to you or not, right? Okay, you guys are not responding at all. Yes, students, is that clear? Yes, Omkar, Srinivas, Manikanta. Manikanta, I have responded to your question, but you are not responding to mine. Okay, next is for the complex mercury 1, tetrathiocyanato S cobaltate. First thing is, what is the oxidation number? Identify the ligand present. Does ionization isomer for the following exist or not? So this is from coordination chemistry. So first question is, this is your compound, right? That is mercury 1, where mercury is having oxidation number 1, right? Okay. So not mercury, this is mercury 1 tetrathiocyanato S cobaltate. Okay, yes. Now, mercury will have +1 oxidation state and cobalt is having +3 oxidation state. Tetrathiocyanate, that means SCN is 4, right? Okay, and it is linked to sulfur, right? So, first is what is the condition, what is the coordination number of cobalt? So, you just need to find out the coordination number, that is X minus, this is X. See, if it is +1, it will be -1, right? So it is going to be, that's why we have written it here -1, right? So it is X minus 4 is equals to -1, X is equals to +3. So oxidation number is going to be +3 here, right? Coordination number is 4. Coordination number of cobalt is 4. Oxidation number is +3, right? Okay, oxidation number is +3, coordination number is 4, right? Okay, wait a minute. Wait a minute, I think other things we have not written here. Chalo, I'll just tell you that, right? Next, beta, we have the ligand present in this complex. What is the ligand, students? SCN is the ligand. This is the ligand that is present in this particular complex. Does ionization isomer for this compound exist? No. For this ionization isomer will not exist, but for this linkage isomer will exist, because this SCN is an ambidentate ligand, right? So it will have a linkage isomer. It will have a linkage isomer, right? It will have the existence of linkage isomer, right? Ionization isomer means Hg can act as a ligand. Hg cannot act as a ligand, right? SCN cannot act as a counter ion, right? So that is why ionization isomerism will not occur, but linkage isomerism will occur here, right? Next question is, you have a student of second PU performs 2 trials of reactions. He is sitting there performing the reactions, right, between Ki and KMNO4. I think this is from DNF block. In first trial, students add small amount of acid to the reaction mixture. In second, student forgot to add acid to the reaction mixture. Okay. The student observed that different colors were observed in first and second trial. Give the observation. So again, they are telling you about the oxidizing nature of KMNO4. It is a very good oxidizing agent and it behaves entirely different in acidic medium, in neutral and basic medium. So they are saying in one case there is neutral medium, one case there is acidic medium. So how I negative will be converted to two things, I2 and IO3 negative. That is what they are asking you here. So in the second trial, without acid, KMNO4 does not get fully reduced. Instead, it remains in a higher oxidation state. The reaction produces different color due to presence of MnO2, which is a brown precipitate. So firstly, we will see the reaction here. The reaction is, if you talk about with Ki, when you don't have acidic medium, right? So what will happen? Out I2 will be formed and MnO2 will be formed. That is why it will have a brown color, right? But if you talk about in the acidic medium, it will have IO3 negative, right? Okay. So the difference in color observed in two trials is due to presence of acid in the first trial, which allows KMnO4 to reduce to colorless Mn2 positive ions, right? So basically, I think that's not written here, so I'll just write it here, right? So I'll just write that thing over here only, right? So in acidic medium, how it will behave? In acidic medium, I negative is converted to IO3 negative, and KMnO4, MnO4, MnO4 positive is converted to Mn2 positive, which is colorless, But in basic medium, you have basic or neutral medium, you have MnO2, right? And you have I2, right? So that is the reason, while in second trial, MnO2 precipitates, which gives us brown color, right? So answer is going to be this one. Okay, guys, got it? Next is define crystal field splitting. Okay, everybody, important topics of all chapters. Yes, Kanadiga, I'll do one thing. I'll make one video on this topic, okay? That most important topics for PUC2. Okay, I'll make one video on this. You can watch that video. I'll tell you everything in detail in that video, okay? Now, define crystal field splitting. Sketch the energy level diagram for the crystal field splitting of d orbital in the tetrahedral complex. So in tetrahedral complex, that is this thing. So basically, just remember you have 3 above and 2 below, right? So how you're going to draw it? Right? So crystal field splitting refers to separation of degenerate orbitals that were firstly at below energy when you have approach of ligand, right? Basically, CFT is based on electrostatic interactions. So when ligand is approaching, all of them will increase their energy, right? So tell them very, very excited that, okay, this girl is coming to the class, right? So all the boys will get excited that, oh my God, I have to impress her, this and that. After that, what will happen? Some of them will be like over the top, like, okay, too much, totally fan, right? And some of them are like, okay, fine. It's not like that, like we have to give up on studies and everything for her, right? So some of them will get even excited and some of them will get de-excited after that, right? So basically, degeneracy will break here. All the 5 friends who were together, now those 5 friends are not together, right? Because of that girl, now there is splitting of those 5 friends, right? So now in tetrahedral, 3 orbitals are above and 2 are below. The one that are above are called T2. The one that is below is called E, right? In octahedral, it is the opposite. In octahedral, you have 2 above and 3 below. It is called EG. It is called T2G, right? And so this is the thing. Now you can say the ligands create an electrostatic field around the metal ion, causing the orbitals to split into different energy levels. As you can see here, you can also write that tetrahedral have 4/9 of octahedral. This also you can write for extra information, right? Okay, yes. Now, next is, yes, students, I'll definitely do that. Don't worry about that. What is the significance of synergic effect in metal carbonyls? So do you know what is synergic effect? Everybody, what is synergic effect? What is basically synergic effect? Everybody, what is the synergic effect? Synergic effect is back bonding. So we know that this is metal, this is ligand. Ligand always is a electron donor. It is going to donate electrons to metal. Metal is electron acceptor. But sometimes what will happen, metal will be like, oh my God, thank you so much. You have done so much for me. So, this is exactly my situation, our situation. So sometimes what will happen, this is teacher and this is student. This is a YouTube teacher, this is a YouTube student, right? Teacher knows that I have to deliver content, I have to teach the students, right? Students will always take the content, they will never comment, nothing they will do. They will not even speak, right? So they will take the teacher for granted. Sometimes the student will think that, yeah, ma'am is doing too much for us. When at least I can comment, at least I can appreciate the ma'am. So in that case, this is called synergic bonding, when the metal also thinks about the teacher. Metal also thinks about the ligand, and I also have to think about her, right? Okay, so that is called synergic bonding, that they are very much understanding with each other, right? So let us see it in detail. In metal carbonyl compound, CO is a ligand, donate. Now carbonyl is that ligand which donates, right, and which also accepts through pi bonding, right? So now in metal carbonyl, CO ligands donate its electron pairs in vacant d orbitals of metal through sigma bond. Donation is always through sigma bonds. Metal, when it donates its electron in vacant, very, very important, vacant anti-bonding orbital of carbonyl, right? They can ask you, always it is showing pi bond. Donation is, when metal donates, it donates on the pi bond only. In case of carbonyl, it's anti-bonding, right? It's anti-bonding. It's pi star. Okay, it's pi star. Okay, so of CO ligand, this is known as synergic effect or back bonding, right? Okay, how many bridge and non-bridge CO are present in octacarbonyl dicobalt? Basically, this they are talking about. It's a very, very important structure in your NCERT that is given to you, right? So carbonyl, it's a very, very important structure that if you talk about this thing here, so it will form, this is CO, right? This is, wait a minute, this is CO, this is CO, this is CO, this is also CO, right? This is also CO, this is also CO, 1, 2, 3, 4, 5, 6, 7, 8. Right. So now they are asking you how many bridged and non-bridged carbonyl ligands. So how many bridged carbonyl ligands you have? 2. How many non-bridged? You have 6. So these 3 and these 3 are not bridged. But this carbonyl and this carbonyl, they are bridged. Okay. They are in the bridging. So this is cobalt, and in between you have carbonyl. So that is a bridged ligand. Right. Okay. Next, guys, we have direct measurement of conductivity of ionic solutions by Wheatstone bridge is not possible. Give reasons and suggest a remedy to solve it. Now they are saying that direct measure of conductivity of ionic solution. What is a Wheatstone bridge? I think you must have seen this in physics as well. This is also there in physics, right? So I'll just show you that, right? So basically, guys, let me see if there is, okay. Chalo. So now we'll just see this, right? So now a Wheatstone bridge. What is a Wheatstone bridge? Right? It looks like this. This is basically, it looks like this. This is a kind of Wheatstone bridge. It has resistance over here. A Wheatstone bridge is unsuitable for measuring ionic solution conductivity because the solution's resistance, the resistance of the solution is highly dependent on factors like electrode polarization, right? Temperature, right? They may vary. So, which are not easily controlled, right? Electrode polarization, temperature, we can't control that easily. A remedy is used on AC bridge circuit to minimize polarization effect and employ temperature compensation techniques, right? That is why it is not that suitable. To accurately measure the conductivity of ionic solution, use AC bridge or a conductivity meter. So what is an AC bridge? These are the methods. So you can actually, without like, it's a remedy, right? So that you don't need to use this thing, right? So AC bridge alternating current minimizes polarization effect and provides more stable readings. Conductivity meter is specially designed for ionic solutions. It measures conductivity directly and compensates for temperature and other variables also, right? Okay, got it? Okay. Next is, for a reaction, the potential energy diagram is given below. They are asking you, by observing the above diagram, answer the following questions. What is the value of activation energy? What is the value of delta H? Draw potential energy diagram for products to reactants. Okay. So guys, very simple. So activation energy, first they are asking you the activation energy. This is the activation energy. Okay, this is the activation energy. Delta H is, this is for reactants, this is for products. This difference is called delta H, right? So that will be 20 minus 5, right? So let's solve it here, right? So as you can see, right, activation energy is the minimum amount of energy required for a chemical reaction to occur, the threshold for a reaction to occur, right? Minimally it should have, if reactant pass this thing, they can have the, they can get and convert it into the products, right? So here it is activation energies, this is the reactant and this is the EA, right? So this much amount of energy is required by the reactants to get converted into intermediate state. So answer will be 60 minus 20, 40 is the energy. What is delta H? Delta is H is product minus reactants. So it is going to be 5 and this is 20. So it is going to be 5 minus 20. So answer is going to be minus 15, right? Delta H is what? It is HP minus HR. So it will be 5 minus 20. So minus 50, right? Okay. Okay. Next is state Faraday's second law of electrolysis, right? Mention any two factors which determines the product of electrolysis. Faraday's second law basically tells you the ratio of weight and equivalent mass, right? So Faraday's second law of electrolysis, what it tells you, Faraday's second law of electrolysis states that the mass of substance deposited or at any electrode on passing, basically you have two electrodes that are in series, right, in certain amount of charge is directly proportional to its chemical equivalent weight, right? That means the mass of substance that is deposited is directly proportional to the equivalent weight. So if you have two things that are connected in series, you can say that WA by EA is equals to WB by EB is equals to WC by EC, because they are directly proportional, so the ratio is going to be constant. Or we can also define it like when the same quantity of electricity is passed through several electrodes, I have written several electrolytes, the mass of substances deposited are directly proportional to their respective chemical equivalent or equivalent weight, right? So mathematically this is the case. Okay, understood? Yes guys. Next we have name two components present in binary solutions. Which component determines physical state of binary solution? Binary solution means which has one solute and one solvent, right? A binary solution, two components, a solute and a solvent, right? Now they are saying which component determines physical state of binary solution. So the one which is more in quantity. So solute is less, solvent is always more in quantity. So solvent is going to define the nature, the physical state of that solution, right? Large amount and determine the physical state. That means solvent, the solute is the component present in smaller amount and dissolves in the solvent. So solvent will tell you the physical state, right? Okay. Next question is, how do you distinguish? Next students, they are asking, how do you distinguish between primary, secondary, tertiary amine by using Hinsberg reagent? Right, chemical reactions involved. It's a very, very simple question, right? So basically, to distinguish between these three things, for example, this is pH means this is benzene. pH means they are talking about benzene here, right? So we have written it as phenyl. SOCl2, what will happen? This hydrogen and this Cl will be eliminated. Hence, you will have the formation of SO2NHR. SO2NHR. Now, what will happen with the primary amine? The compound that will be formed because of this hydrogen here, it will be soluble in the alkali. If you talk about secondary, this Cl and this hydrogen will be eliminated and this will be the answer that is formed here. But in this case, you don't have any hydrogen, that is why this is insoluble in the alkali. Talking about this thing here, this is tertiary. It does not have any hydrogen which can react with this Cl here, that is why this is going to be no reaction here. Alkali means like NH4OH, right? Okay, understood? Next question they are saying, give the preparation of para-hydroxyazobenzene, right? Now basically students, if you have para-hydroxy, they're talking about hydroxy. That means You can see it like this. You can also see it like this. Let's see it like this. This is benzene. This is N2Cl. This is benzene, right? And this is phenol. From the para position, this H and this Cl will be eliminated, and hence you will have the formation of, if I write it this way, the Cl and H will be eliminated, and these two will attach together, and this is the thing that you will have, para hydroxyazobenzene, which is orange in color. This has orange in color. Azobenzene is formed. With aniline, yellow color is formed. Okay, with aniline, yellow color is formed. Yellow color dye is formed. Okay, understood, guys? Yes, students, everybody understood? Shall I move with the next question here? Students, if I am not visible and audible, then let me know. Right? I to think you guys are not interested only. If you're not interested, then let me know. I will not teach chemistry section here. Right? I think you guys hate chemistry or what? Haters of chemistry. Yes, students, tell me in the comment section what you want. Next is, between methanol and ethanol, which would undergo aldol condensation? Write the chemical reaction involved in it. Methanol and ethanol, which will undergo aldol condensation. Right, so both we can undergo aldol condensation, right? Okay, between this and this, which would undergo aldol condensation. So cross aldol condensation will happen here. So what will happen here? You can just directly write this thing, right? Okay, cross aldol condensation. I'll just tell you a very simple method. So basically, not one product will be formed, so many product will be formed here, right? So just written one product. I'll just tell you so many products will be formed here, right? So write chemical reaction involved in it, right? So if you talk about methanol to methanol, methanol means CH3, C double bond O, H, and I'll just write it on the next page. If you talk about methanol and methanol, this is C double bond O and this is H. Plus you have CH2 and this is H and this is CHO. So what you will do, you will attach the carbonyl carbon with the alpha carbon, and you will have the formation of new product here. New product will be formed, that is CH3. This double bond O is converted to OH, right? And this hydrogen is shifted here, right? This is CH2, this is CHO, right? Okay, this thing will be formed. After this, OH and hydrogen from here will be eliminated, and this is the answer that you are going to have, right? Second is if you have ethanol and ethanol. Ethanol means, so this is ethanol, na? Ethanol will form this thing. If you have methanol, methanol does not have alpha carbon, right? Methanol does not have alpha carbon, so it will not do self-aldol, right? It can react with this ethanol, right? And it will form the following compound, because what will happen? This has alpha hydrogen, so what will happen? The carbonyl carbon of this will attach to the alpha carbon here, and answer will be, this is CH2, this is CH2, this is CHO, and here you will have the attachment of this CH2 and this is OH, right? After that, what will happen? This OH and this H will be eliminated to form this double bond, and this is the answer. These are the two answers that you will get. Ethanol will react with ethanol will react with the ethanol. Ethanol will also react with methanol. Methanol cannot react with itself because of Cannizzaro reaction will happen in that case. But we don't have Cannizzaro, there is no mention of Cannizzaro reaction here, right? So that's why we will only show the aldol condensation here, right? Okay. So next is although phenoxide ion has more number of resonating structure, why carboxylate ion is a stronger acid than phenol? So this is the reason here is equivalent structures, right? If you talk about the phenol, no doubt it has 5 resonating structures. We say that when it has more the number of resonating structures, more is the stability of that compound. But in this case, why carboxylate ion, which is having just 2 resonating structure, it is more stable? Reason is these 2 resonating structures are equivalent in nature. Equivalent in nature. Equivalent structures. Equivalent structures, and equivalent structures have more stability as compared to number of resonating structures. Right? Okay. Now, next is what is peptide bond? Give an example for dipeptide. Peptide bond means the bond between amino acids, right? That is peptide bond, right? So let us see that here, right? Firstly, let us see what is a peptide bond. Firstly, let us see what is a peptide bond. The CONH, basically what is a peptide bond? CONH, CONH, linkage. That means when you have 2 peptide bonds that are linked together, linkage amide linkage when you talk about, by which alpha amino acid are joined in a linear fashion in protein is called peptide linkages, right? So basically when your amino acids are linked to each other in a peptide bond, that is called that means protein chain, protein polymer is formed there, so that is called peptide linkage. Peptide linkage or dipeptide is formed by condensation of acetic acid. So what will happen? Let's say you have amino acid which is having COH and amino acid which is having NH2. So amino acid will have both NH2 and COH, right? So we are taking, for this amino acid I am taking the part of COH, for this amino acid I am taking the part of NH2. What will happen? Water will be released from this side, right? And you will have the formation of this to this oxygen, you will have C double bond O. This nitrogen is attached here, right? This nitrogen is attached, wait a minute, this is H2O. H2O will be taken out, right? Water will be eliminated, right? So H2O will be taken out, this carbon, then you have NHCH, NHCH, this thing. So that is called dipeptide linkage, okay? That is called dipeptide linkage, right? Next is, what are oxidoreductase. Oxidoreductase enzyme is which shows both oxidation and reduction. Name the enzyme that catalyzes hydrolysis of maltose to glucose. So the enzyme oxidoreductase catalyzes oxidation reaction where the electrons tends to travel from one form of a molecule to the other, right? So that is called the oxidoreductase enzyme. Next is given in one mean natural source of vitamin K. So that is there in leaf, vegetables, kale, spinach, green leaves, right? Swiss chard, then mustard greens, all of green vegetables basically, they will have vitamin K, right? Next is, complete the following reaction, guys. So this is exactly from your NCERT, they have picked up this thing, right? Okay. Okay. CS students, CS, can you just define the full form? CS students, complete the following equation. So first is HBr, then you have something from Wood's reaction, you are making this something, then you have this Dow's process, then what is Sedgwick rule, they are asking you to explain, right? So one by one, wait a minute. Okay, I think this answer has not been written, so I'll just write it here, right? So basically, if you talk about this part here, this is positive and negative. So what will happen? Negative part will be attached to less number of hydrogens. That means this part. So it will be C, CH3, this is H, this is Br, this is CH2, and this is H. So this thing will be formed because Markovnikov rule will it will follow Markovnikov rule. This is Wood's reaction. So you have made double of this thing. So if you had this thing, that is if you had CH3, CH2X, then on reacting with sodium diether, the double of this thing will be formed, that is 1, 2, 3, 4, butane will be formed. So this is the correct answer. Next is from Dow's process, you have the formation of, from Dow's process, OH, Cl is replaced by OH. So you can just write it here, this is Dow's process. Now they are asking you, explain the Sedgwick rule with an example. Anybody, what is Sedgwick rule? Right? Anybody, what is Sedgwick rule? Beta, if you have not touched NCERT, don't touch it now. Now is not the right time to touch NCERT. Right? Okay. So I would advise you, go through the previous year questions, right? Last 10 years, right? Go through the short notes, go through one shot videos, right? And go through your class teacher notes. That's it. Don't go through NCERT, because right now it's not the right time. 1 month before, if you ask me to do study NCERT, then that is not the right thing to do, right? So explain Sedgwick rule with an example. Sedgwick rule means that whenever we talk about, for example, they are asking that which is more stable. If they're asking whether this is more stable or this is more stable, right? They are asking this thing or they are asking you this thing. Now, as I can see, to this double bond, we have 2 alkyl chains here. Here I have just 1 alkyl chain. So this will be more stable. So basically, Sedgwick rule says that the one alkene which is highly substituted, right, which is highly substituted, highly alkylated, that is going to be the major product always, right? And this is based on the hyperconjugation. This is based on hyperconjugation. Hyperconjugation means more the alpha hydrogens, more is the stability. It has 6 alpha hydrogens, so that's why it is more stable. It has only 3 alpha hydrogens, so that is why it is less stable. Okay, got it? Now, next question is, give the chemical equation for the conversion of propane nitriles into corresponding ketones by using phenyl magnesium bromide, right? IUPAC naming of the product. Okay. So chemical reaction, they are asking you for propane nitriles to corresponding ketone, right? Using phenyl this. So this is Grignard reagent you are using, right? Okay. 1, 2, 3. Conversion of this to corresponding ketones. So if you have pH MgBr. So students, here what will happen? This is positive, this is negative, and if you talk about this thing here, this is triple bond N, this is negative, this is positive. So we know that negative is going to attack on the positive, electrons will shift here. So what will happen? This is CH3, this is CH2, this is C double bond N, and this is going to be pH, right? And here it is going to be MgBr, because this positive is going to attach to this negative nitrogen. Now, after doing hydrolysis, this thing will be, or you can just directly write here, after doing hydrolysis, this whole product will be changed to double bond O. So this is going to be the corresponding ketone that you will have. Write the IUPAC name of the corresponding ketone. So what you will have, this is C double bond O, and this is CH2 CH3, right? Ethyl phenyl ketone you will have here, right? Okay, that is going to be the answer. Explain HBZ reaction. Okay, so this is the first. Okay, so this thing will be formed. Next is explain HBZ reaction, Helmholtz-Zielinski reaction. In this case, you will use Br2 in presence of phosphorus and you will hydrolyze it. Now this alpha hydrogen over here, this is the alpha hydrogen, 2 alpha hydrogens you will have. Alpha hydrogen attached to the carboxylic acid, that will be replaced by the halogen that you will use in this case. So alpha monohalo compound will be formed, that is called HBZ. The reaction involves alpha bromination of carboxylic acid carboxylic acid react with chlorine or bromine in presence of small amount of red phosphorus to give alpha halocarboxylic acid will be formed here. Right? Okay. Next question is, write the reaction involved in the mechanism of acid catalyzed dehydration of alcohol to alkene. Acid catalyzed. The mechanism is simple. You will have the formation of carbocation here. That is why always and always do this with the help of rearrangement of the carbocation. Right? So let us go through the mechanism here. Let us go through the mechanism here. Very, very simple mechanism. If you see this mechanism, guys, so this is basically what will happen. Lone pair of oxygen, you have H positive from the acid, right? It will tie to oxygen. Lone pair will be like, I want to take proton because I'm electron rich. This is electron deficient. So H positive will be attached here. Oxygen now has 3 bonds. So that's why there will be a positive charge on the oxygen, right? After that, oxygen will be like, I am an electronegative compound, electronegative atom. Why would I have positive charge on me? I should have a negative charge. So that's why electrons will be eliminated from here and you will have the formation of a carbocation. After that, what will happen? Again, this water will attack here, and from water, what you will have, this water lone pairs. They will be like, array, I am having lone pairs. So I want to take out H positive from this side. So carbocation, so H positive will be taken out here and this bond will shift here and you will have the formation of alkene here. And you will have the formation of alkene here. That is the full mechanism. Next is, explain the preparation of anisole by Williamson synthesis reaction. See, this is anisole. Anisole is OCH3. Williamson synthesis is when you have RX plus RONA, it gives rise to ROR plus NaX. That is the general reaction. First, you will write the general reaction, right? Okay. Then you will give the example, not the example. Then you will tell that what exactly happens in case of anisole. Why we have not used CH3ONA and why we have not used benzene with halide. Why I have not used phenyl X and CH3ONA. Reason is because this is a bond, it is having a double bond character, so it's very difficult to break this bond. So you will also explain that thing here. So that's why you will say that this reaction cannot occur. This reaction cannot occur. That is the reason we will use sodium phenoxide ion, right? Sodium phenoxide with methyl iodate. Sodium phenoxide ion with methyl iodate, right? Okay. Now, next is show that in the first order reaction, time required for completion of 99.9% is 10 times to half-life of T half. Yes, everybody? Everybody in the comment section? Yes, everybody? So let us see that. Right? So 99.9% completion is there. That means we can say initial is 100 and final is 100 minus 99.99. Okay. Okay. So you can just write this thing here. We know that show the first order reaction time required for completion of this is 10 times the half-life of T half. So you need to take T 99.9 divided by T half. Right. So this is T half, this is T 99.9. In T half, here I have taken it as 100. Right. If you want to ease the calculation, you can just take it as A naught or A, whatever you can take. They have taken it as A. So I'll take it as A only. So this is initial. Final is from initial subtract that amount. So that is 99.9. A will be subtracted from here. For T 50%, you will subtract A by 2 from here. So A by 2 is subtracted from here. Right. Then you will just do the calculation. A will be cancelled out because here it will be. Let me just write it down. Here A will come out to be. This will be cancelled out. This will be cancelled out. This will be log. Right. This will be log. This A. This is A. right? This will be cancelled out. This will be 1 by 0.001 because 1 minus 0.999 is 0.001 only. Divided by this is log. This will also have a, you take out a as common, take a as common, take a as common, that is cancel out. It is 1 by 2, so it will be 2 over here. So it is log 2 only, right? It is log 2 only, right? So it is 1 by 2, so it is going to be log 2 only, right? So it will be log 2, it will be log y minus of this. If you take it as this will be log 0.001 minus 1 divided by log 2. What is 0.001 minus 1? That is minus of log 0.001 divided by log 2. So you just need to solve this. That is nothing but this is minus log. This is 10 raised to power minus 3 divided by log 2. Minus 3 is nothing but it is 3. So it will be minus of minus. This will be 3 log 10. This will be log 2. This will be log 10 is 1 only. So it will be 3 by log 2 is nothing but it is 0.301. So that is going to be the answer. So it is 3 by 0.301. That is going to be the answer. So you can say T99.9 divided by, if you just take it as 0.3 only, if you take it as 0.3 only, so it will be, if you take it as 0.3 only, right, if you take it as 0.3 only, so it will be 10 here, 3 will be cancelled, it will be 10, right? So here answer will be by T half is equals to 10. So T99.9 is equals to 10 times of T half. So that is going to be the answer, right? Okay. Charan, I have taken one lecture on log and anti-log on this channel only. Just go through this, you will get to know about it, right? Okay, yes. Now, next is a 5% solution of cane sugar in water has freezing point 271. Calculate the freezing point depression constant. That means they're asking you about Kf. Given freezing point of pure water is given to be this. So firstly, we know that delta Tf is equals to molarity into Kf. So Kf will be equals to delta Tf by molality. Kf is equals to, Kf they are asking you, delta Tf is Tf naught minus Tf, right? Because there is depression in the freezing point, so the final freezing point is lower. This is the molarity. So this is the formula that you're going to use. What is molarity? Molality is number of moles of solute by molar mass multiplied by weight of solvent multiplied by 1000 if all of them are in grams, right? So now weight by weight percentage is given to be, students, if I just put this value here, it is going to be, Kf is going to be Tf naught minus Tf, right? Chalo, I'll not put it there. You can just put, I'll just use, put the value here. M is equals to W2 by M2 multiplied by W1 multiplied by 1000. Now guys, you need to understand one thing, that here we are talking about that calculate the freezing point depression, right? 5% weight by weight is given to you, right? So that means 5 gram of cane sugar in 100 gram of solution. Can I say that W2 is equals to weight of cane sugar is 5 gram. Weight of solvent is equals to 100 minus 5. 100 minus 5, that is 95 grams. Right? And M1 is equals to that, so you can calculate, that is 12 into 12 plus 22 into 1 plus 11 into 16. Right? Okay. So this is what you will need to do, and simply we'll just calculate it here, right? Okay. So molar mass is given to, we will calculate it as 342. Just put the values there and you will get your answer. So molality will just put the values on this molality, W2, W1, and then you put the value of M2, that is 342, right? Put the value, you will get the value of molality, right? Here they have given the freezing point. TF is this and this is TF naught. Given the pure water is having this freezing point. So just put all these values and you will get your answer, right? Okay. So by this you will get your answer. Got it? Yes, everybody. So I think that's all what was given to you. Let me see if any other question given freezing point is this. They are asking you about the KF, right? Okay. Understood? Now from there you can just calculate the value of this. Understood, na guys? What you need to do? Put the value of W2, M2. This is M2, okay? This is not M1, this is M2. Put the value of M2, W1, multiplied by 1000, you will get molality. Put the value of molality. TF naught is this one. That will be 2.15. This is going to be 2.15 divided by molality. What is molality? You will just solve this. Molality will come out to be 0.1537. 0.1537. And here you will get your answer of KF. Okay? Yes. Now, next question is, the molar conductivity. That means they are asking you this thing, right? Of this is the concentration that is given to you. Concentration, that means molarity is given to you. Molarity, right? Of methanoic acid is 46 point this. Molar conductivity is given to be 46.1. Right? Calculate its degree of dissociation. That means alpha you need to calculate. They are giving you limiting, the hints for limiting molar conductivity. Limiting molar conductivity, students, that is for CH3COH is going to be limiting molar conductivity of not CH3, it is HCOH is going to be limiting molar conductivity of HCO negative, that is 54.4, 54.6 plus 349.6, right? This will be the limiting molar conductivity, and from this, right, and from this they are asking the degree of dissociation. You need to do all of these things, so you don't need to do, right? You don't need to do this thing here, that is not even needed, right? Because they are asking you the degree of dissociation, right? They are not asking you the value of Ka, right? So degree of dissociation, you will just calculate this and this will come out to be 404.2, right? This will come out to be 404.2. After this, alpha is equals to molar conductivity at C concentration divided by molar conductivity at infinite dilution. So it will be 46.1 divided by 404.2. That is going to be the value of degree of dissociation, right? That will come out to be 0.114. Okay, that will come out to be 0.114. But just do the calculation, you will get the answer. Okay, that's all. You don't need to get into all these things, right? Okay, this is they are solving the dissociation constant. If they ask you to solve the dissociation constant, we know that if this is C, this is 0, initially 0. If I say C minus C alpha is taking out, C alpha is formed, C alpha is formed. So dissociation constant will be C square alpha square 1 minus alpha, and CC will cancel. So it will be C alpha square by 1 minus alpha. Alpha is very small, so it will be C alpha square. So Ka is going to be molality. So dissociation constant, if they ask you, is equals to C alpha square, right? C is what? C is given to be 0.025 multiplied by alpha is 0.114 square, and this is going to be the answer of dissociation constant. Okay, yes. Now, next is Henry's law constant for molality of methane in benzene at this is this. So basically Henry's law constant for molality of methane in benzene is given to be this. This is Kh. Calculate the mole fraction of methane in benzene under this pressure, pressure is given to you, right? They are asking you the mole fraction, right? So just apply the Henry's constant, that is P is equals to KH into mole fraction. Mole fraction is P by KH. P is given to you, KH is given to you. You will get the answer, right? So just simply apply this formula, do the calculation, you will get your answer, right? Simple question. Two electrolytic cells, right? Last two questions, guys. Last two questions. Last two questions are two electrolytic cells, right? A and B containing solutions of AgNO3, CuSO4 respectively are connected in series. We are saying that you have two electrolytic cells A and B containing solutions of AgNO3 based on Faraday's second law, right, are connected in series. A steady current of 1.5 was passed through them until this much is deposited at the cathode on cell A. How long the current flow, what mass of copper was deposited? Okay. So it uses both the laws, Faraday first law and Faraday second law also. So W is equals to ZIT, that you have to use. Then you have to use W is directly proportional to E. These two things you have to use here. So if you talk about this thing here, for cell B, which is silver electrode, right, here we are using W is equals to ZIT. Okay. So ZIT. IT is nothing but it is Q. We will just find the value of Q here. Q will be is equals to I into T. What they are asking you is they are asking you, wait a minute, a steady current, they have given you I, pass through them until this much of W. W is also given to you, is deposited at cathode. Okay. Okay. Simple. So firstly, you need to find out from W is equals to ZIT, right? So time they are asking you for Ag. So that will be W of Ag divided by Z and I. I is given to you, W of Ag, that is given to you. Z we can easily calculate. You just have to multiply this. I'll just tell you, that is, you have to multiply this. So for example, Q is equals to IT, right? Wait a minute. So this is going to be that you have Ag positive takes one electron, it forms Ag. This is the silver that is deposited. Now 1 mole of this is deposited by this much Faraday. 1.45 Ag will be deposited by 96500 multiplied by this divided by this. This is the actual thing, or you can just directly write it as this is F into W divided by wait a minute, W is equals to ZIT. You just write the formula directly. T is equals to W by ZI, right? Okay. T is equals to W by ZI, right? And this is going to be T is equals to W by ZI. This is weight. Weight of Ag is already given to you. This is number of Faraday, right? And this is the weight, molar mass divided by this is the number of Faraday, right? Number of, you can say NF, right? M by NF. Z is equals to M by NF. M by NF, this is W and this is I, right? You just need to put this formula. 1 electron is taken here, so N is 1. Faraday is 96500. W is 1.45. Molar mass is 108 multiplied by I is the current that is given to be 1.5. Okay. You just need to solve this value. You will get the value of T here, right? After that, they are saying they are comparing this with the zinc, other electrode, right? They are saying that how long the current flows, the mass of the copper. This is not zinc. Wait a minute. Two electrodes A and B containing AgNO3 and CSO4 respectively are connected in series. the steady current was passed through them until this. Okay, so we have taken out for copper, for silver we have taken out that the current that we are going to form here is 864, right? Current that we are forming here is 864, 1.45 only it is, na? So 1.45, yes, Q is given to be 1.45, okay, right? So this is the first thing that we have done here. Now guys, just give me a minute, I'll just correct this. Okay, just give me a minute. Okay, I'll just correct this. It should not be like this. Okay, because we have only copper, we don't have zinc. Okay, we don't have zinc. Copper and Ag are in series with each other, so that's why there we will follow the second law of Faraday, that is W of copper by equivalent weight of copper is equals to W of Ag by equivalent weight of Ag, right? Okay, that is the thing that we can follow here. I think they are asking you the time here, right? Wait a minute. Let me just see whether they are asking you time or what. How long did the current flow? What mass of copper was deposited? Now they are asking you about the copper, right? Okay. So for copper, we know that 2 electrons we will take, and it will have the formation of, we will have the formation of CO here, Cu here. So 2 moles of electrons, that is 2 Faraday of current, will produce 1 mole of copper, right? 1 mole of copper means 63.5 gram of copper, right? That will be produced by 2 moles of electrons, that is 2 Faraday. Now here what amount of current you have? The current that you have is 129.56 of current will be deposited, right? This much current, because they are connected in series. When they are connected in series, the current is going to be same here, right? There is no change in the current here. Q charge is going to be same here because they are connected in the series, right? So that's why charge is same in both the cases. That was the benefit of Faraday's second law. So this much of current was deposited, right? Same thing we will do here, right? This much of current was deposited, that is this is for 1 mole, right? Multiplied by the same thing that you had here is 1.1295.6, this much, right? So basically what you can just write here, that 1 mole will give rise to 63.5 divided by 2 Faraday, right? And this much of charge will give rise to 129.5.6 Faraday, right? So basically what we did here, right? You can just calculate the firstly time here, right? Time will be calculated firstly in this case, right? If they ask you the time. Charge is same in the series, okay? Same charge will be produced here. So that is the reason, firstly after calculating the charge on the first case, because the second electrolyte is also in series, we'll put the same case in the second electrolyte and we'll solve the time for that one, right? Okay, so that is done here. Next is the rate constant of a reaction is given by log K is equals to this much. Calculate the activation energy and pre-exponential factor of this, right? So just need to compare it with the equation. So if you see the equation here, this is the equation that you have, right? So K is equals to Arrhenius equation. A is the Arrhenius constant, E is the activation energy. Take the natural log here. Natural log of K is equals to natural log of A minus E and natural log will cancel out each other. That will be A by RT. Now this is given in log. So I'll multiply this by 2.303. So multiply this by 2.303, this by 2.303, this not by 2.303. That means just divide all of them by 2.303 because we need to take it here, right? Okay, so that will be log K, log A minus EA by 2.303 RT. Now you compare it here. We know that log of A is equals to 13.25. Log of A is equals to 13.25. And this T, you can say EA by R is equals to 1.28 into 10 raised to power 3. Right? Okay. So after that, just multiply these two things and you will get your answer. Right? Okay. Take the antilog here, calculate the activation energy and pre-exponential constant. A is the pre-exponential constant and E is the activation energy. Okay. R is the gas constant. Right? Okay, guys. So guys, that was all about model paper 1. If there is any problem, you can always tell me in the comment section. And I would like if you guys are more interactive in the class, right? Okay, so that would be much better for this class and we can have more fun in this class, right? Okay. Okay then students, bye bye, take care, see you all in the next class. Till then, take care of yourself and keep studying. Keep practicing the questions as much as you can. Okay, bye bye. Bye Charan, bye Abraham, bye Karnataka. She was saying something. Ma'am, tell me what I can do by education instead of earning money and doing jobs, which is a big doubt for me. Can you please clarify, ma'am, if anything wrong in asking them this? Sorry to say, ma'am, at least. Okay. What is the use of education? Use of education, it depends on what you say is education. Education is not just about learning these stuffs. Education is about knowing the knowledge of things. Education is when someone gets ill, you know that, okay, they need a doctor. What is the need of a doctor? You know health consequences, that what can happen. Education teaches you that. You know that how to behave in society. I'm not saying the one who are not educated, they don't know how to behave, right? So education does not depend on whether you are 12th pass, you are uh, PhD or what, right? Education is the knowledge what you have, right? So you everything, all the etiquettes you learn is for education only. But what you see education is a different perspective. I see education as learning things, whether it's from official and professional way or whether it's unofficial way. When you learn things, if your mother is your best teacher, right? So when your mom teaches you something, right, your mom may not or may be very well educated or not, but she is knowledgeable, right? She knows that this is good for my kid, this is not good for my kid. So that's where education and knowledge plays the role, right? Okay, chal, bye bye guys, take care, see you all in the next class. Bye bye.